I'm Jeff Gerard, President and founder of the Concrete Countertop Institute and the instructor of our hands-on classes. I'm pleased to be here today to present the Diamond Polishing online training session. So what is polishing? Well, the Concrete Polishing Association of America defines it as, and this is regarding floors, the act of changing a concrete floor surface with or without aggregate exposure to achieve a specified level of gloss. I wanted to start out with a point towards floor polishing, and some of you may do floor polishing, but what I'm going to be addressing is polishing concrete countertops and other flat architectural pieces that are usually done by hand, and there are some similarities and some differences. Polishing is a process of removal and refinement. Basically what we're doing is we're taking a surface of concrete and removing material not only to achieve a given degree of appearance or aggregate exposure, but also to make the surface smoother and smoother. And one hallmark of high-quality polished concrete is that it has a very high gloss and a very flat surface for very crisp, low distortion reflections, as you can see in this picture. Some of the similarities between floor polishing and concrete countertop polishing is that we use very similar diamonds or the same diamonds. The tooling is similar, the processes are similar, and I'm going to go into those. But it's the differences that I want to point out in the beginning, because I'm not going to be addressing flooring. With polishing floors, there are large machines that are used to hold diamond pads of various grits in various configurations, and it's the floor machines that apply a uniform and repeatable pressure. So some machines weigh only a few hundred pounds, some machines weigh up to 1,000 pounds. Some machines have a very rigid flat head that is designed for leveling a floor. Other machines have flexible heads that are designed to glide over a surface and not take out high spots. The pads just ride over the surface. So different machines give different results, but it's the machine that does the work. Of course, there has to be some technical skill and experience in terms of selecting the right diamond pads to match it to the concrete and dealing with the whole process. But I want to point out the fact that it's the machines that make flooring, concrete polishing flooring, so effective and so appealing to some people. When we do it by hand, there's some different processes and different things that we have to pay attention to that are not necessarily mirrored in the flooring industry. So I just wanted to point that out in the beginning. The surface profile, what makes polished concrete shiny, is the actual texture of the surface. If you've ever looked at a sidewalk, especially a broom finish sidewalk, it's rough, it's uneven, it's dull, it tends to look lifeless. There's absolutely no sheen to it. And one of the characteristics of a surface like that is that a rough surface, and I'm talking about not just a physically rough surface, but an optically rough surface, it scatters white light. So you can have a sidewalk, for instance, and when it's dry, it looks light and pale and rather, dull. But if you put water on it, all of a sudden the color comes out, and because the surface, the water looks shiny, and you can see a whole lot more. The whole appearance of the wet sidewalk has changed dramatically. And what's happening is the water is basically optically smoothing the surface, and so sunlight, instead of being scattered and making the surface look dull and washed out, is instead reflected and transmitted down to the surface, where some of the color is absorbed and what's reflected is more or less the true color of the concrete. And what polishing does is it does a similar thing, but instead of using a coating, water in this case, on the sidewalk example, is a coating. when you polish the surface, you're gradually making the surface smoother and smoother and smoother. And so all the roughness from casting, the roughness from finishing, and the scratches and roughness from the early grinding and honing are made smaller and smaller and smaller. And so by the time you get down to a surface that looks to your eye to be very shiny, what you're really seeing is a surface that has scratches that are so smooth and so small that most of the visible light is reflected rather than being scattered, and that's why it looks shiny and glossy, and that's why the color, as the more you polish concrete, the more the color of the concrete comes out, because you're not scattering so much white light, you're getting more and more of the true color of the concrete. So what are the key requirements for polishing? It's not just using diamonds on concrete. You have to have three things, and I'm going to talk about each one. One is you have to have quality concrete, and it has to be well cured. You can't take garbage concrete and make it shiny. Second, you need to have good quality diamond pads and the right kind of diamond polishers to operate those pads. And third, you need chemical treatment. You have to chemically treat the concrete with densifiers. So I'm going to talk about each one of these topics and how they all work together to achieve that high level of gloss. Let's start with the concrete. First, you have to make good concrete. And the Concrete Polishing Association of America specifies a minimum compressive strength of 3,500 psi. So it's probably around 22 MPa for my metric friends. I think that's rather low. Good concrete, countertop concrete is generally much stronger than that. So I'm going to say about 5,000 psi. So we're looking at 33, 34 MPa, maybe a little bit higher. That's a minimum. It's very easy to achieve much higher strengths, and I think that is part of the key to being successful. Another factor is you need to have concrete with a low water cement ratio. If you have concrete that has a lot of water in it, it's very porous, you're not going to have good concrete, you're not going to get good strength, and you're not going to get a good polish. The concrete should have sound aggregates, and by that I mean hard, strong aggregates. Let's use a wild example of saying you made concrete using pieces of styrofoam or chalk or something soft or something very porous like a lightweight aggregate. You're simply not going to get a good polish because you can't polish something soft, you can't polish something that crumbles, and you can't polish air. And that leads me to the next element of the concrete is that you have to have a dense composition, meaning the best polished surface is one that has very few voids in it. So a concrete that's very dense, has good aggregate packing, is going to achieve a much better shine than one that has lots of air in it, lots of excess cement cream, poor aggregate exposure or aggregate gradations, and so on. And that I'll get a little bit more into some of the implications of that as we move on. And finally, and I think this is the most important element, is the concrete has to be well cured. You cannot polish concrete that's 1 day old unless you happen to be using concrete that attains its full strength in 1 day. Portland cement-based concrete takes time to develop, and what we're dealing with is turning a very non-uniform, uneven material of hard aggregates of various sizes bound together by this changing glue, the cement paste. It takes time for that cement paste to fully incorporate, to get hard enough, to get strong enough to bind everything together. And if you start polishing too fast, you're just not going to get good results. So the longer you wait, the better off you are. In fact, for floors, it's minimum 28 days for the final polish. They can start the early cuts sooner, but the final polish is minimum 28 days. So I'm going to say similar things for concrete countertops. You have to be patient for this to get a good result. I had mentioned surface porosity. If you have concrete that has a lot of pinholes or voids or bug holes in it and they're not filled, your concrete's not going to look shiny because pinholes, you can't polish air, and they're always going to make the surface look duller. If you have a lot of micro fissures in your concrete, or your concrete paste is soft, it will crumble, and the crumbling has two effects. First of all, the surface constantly looks rough because you're never machining it. Like if you can imagine a piece of steel that's rough cast and you keep machining it, the steel is very, very hard, and the surface gets smoother and smoother, and it doesn't degrade. Well, if your concrete's really soft or it has a lot of surface fractures or surface voids, the diamonds, especially coarser diamonds, can start tearing the surface and chipping those edges, and they constantly break down, and that surface is never going to look shiny. In addition, all that dust and those pieces that fracture off will actually damage the surface, and I'll show you examples of that later on where you actually see scratches in the concrete. So a good casting, one that's well vibrated or well dense, cast very dense, is going to give a better appearance. If you do have voids, you need to grout them. That grout needs to cure fully, again, to fill those holes, to give yourself a nice hard surface. And finally, the chemical processors, chemical treatments we use, or sometimes they're called densifiers, sometimes they're called hardeners. They don't fill in pinholes. These are not pore filling or hole filling materials. They're chemical treatments that change the concrete itself and change things on a very microscopic scale, on the micrometer scale, not the millimeter scale. I had said higher. You want good sound aggregates. Very hard aggregates take a shine very, very nicely, and the harder the aggregate, the better the shine, and the harder the whole surface is, the concrete, the paste, the aggregates, etc., the harder that whole system is, the better and more even the shine is. So what I've done is I've shown a picture of just the opposite of that. What you're seeing is a photo of the same thing. The photo on the left is sort of a close-up, and the photo on the right is a very much close-up of part of that bright spot in the middle. And what you're seeing is a GFRC face coat, that's glass fiber reinforced face coat, that has a decorative aggregate. In this case, it's a quartz aggregate that's been mixed into the visible surface of the GFRC. And this piece was ground and polished 2 days after casting. And quartz is a very hard material. It's got a hardness on the Mohs hardness scale of 7, which is about the same as granite. Granite can be 6, 7. Sometimes it has some minerals that are a little harder, like up to 8. Diamond is 9, so diamond's one of the hardest, is the hardest natural material. Quartz is very, very hard. Glass is about 5.5, just to give you a scale. So any material that's around a 5.5, 5, 5.5, 6, 7 is going to polish to a very high gloss, very even sheen, very bright reflective surface. And if you look at that bright spot, which is a reflection of the overhead lights in my shop, the long line is a fluorescent tube. The circular area is an overhead, like a high bay light that you'd use in a warehouse. And the dull areas, the white concrete that's around it, looks dull. There's some tiny little specks in there, and those are the sand grains. The reason the concrete is dull is because it's only 2 days old. It's far too soft to take a shine. And what's actually happened is, in the polishing process, we've actually eroded the surface. So it's kind of like sandblasting the concrete. It's always a rough, uneven surface, so we're never achieving a smooth polish. And that's why it's so important to give your concrete time to cure. Because the cement paste itself needs to get hard enough, needs to tie itself together, become chemically receptive to the densifiers that further harden it to allow you to polish it to a high shine, to where it looks more like a solid uniform surface. And that's part of the treatment process that's done and that I'm going to talk about. So this is a good example of what happens when you jump the gun too fast and you try to polish it. You're actually hurting the concrete, because now you have to wait. So all the work you just did is useless. So you shouldn't have done it in the first place. And then you have to fill in any low spots that you've eroded, because the sand grains around those particles are not even with the surface. They're about a 0.5 millimeter low. So now we have to either grind everything down to below the rough surface to get it even again, or fill everything in. Either way, that's a whole lot of extra work. So sometimes it's just better to be patient and wait than it is to get going too fast, and now you take 1 step forward and 3 or 4 steps back, and then you have to retrace all those steps all over again. here's what I would talk about the Mohs hardness scale. Concrete in general, and this is a really broad range, and this accounts for all types of concrete you're going to encounter, floors and sidewalks and things like that, 4 to 8. So if you look on the scale on the left, the vertical scale, talc is one of the softest natural materials. You can scratch it with your fingernail. Dense limestone, marble, sandstone, that's about comparable to ordinary concrete. If you look at as you cut deeper into the concrete, you get into more and more of the aggregate. The surface that you see is really defined by the hardness of the aggregate that's exposed. So if you have a lot of hard quartz and basalt and things like that, it's going to polish very nicely, as I've just shown you. In contrast, if you don't expose that, if you leave a cement cream finish, that's going to behave more like a softer limestone or a marble. It's a much softer material. The cement paste itself never gets really very hard. So if you see this scale of 4 to 8, that's sort of a broad range, and that 8 could really be referring to the majority of the coarse aggregate that's exposed in the floor. If you're not exposing the aggregate, you're not going to be encountering something that hard. So it's always very important for you to be aware of what the look you're trying to achieve, a cement cream finish, a light sand exposure, or sometimes called a salt and pepper finish, or if you're actually going to go for an exposed aggregate finish, the more of the hard aggregate that's exposed, the more the whole system is really governed by the hard aggregates, and you have a little bit more freedom when you have very hard aggregates. But you do have to pay attention to that soft cement paste that's binding everything together, as I just showed you. And on the right, there's a scale of just other common household objects. So your fingernail, a copper American penny, a glass, there's about 5.5, a steel knife. Although metals are hard, they have a hardness of about 7. And you can test that by taking bare concrete that's got exposed quartz and actually cutting on it with a steel knife. And usually what happens is you rub the steel off onto the concrete. You don't damage the concrete at all. And that says that the concrete itself is harder than the knife. And that's one of the big benefits of polished concrete, is you have a surface that is extremely scratch and abrasion resistant. It's the most abrasion resistant form of concrete you can have is a heavy exposed aggregate polished surface. And that's why polished concrete floors are so, not only are they popular, but make a whole lot of sense, especially for commercial flooring, because there's very little maintenance to do. And although this is a little bit outside the topic of how to polish, it's important for you to realize that polished concrete, no matter what the concrete is, or whether it's a floor or whether it's a countertop, and what it looks like, is you still have bare concrete. It may be very smooth, it may be very shiny, it may be very non-porous, but it's still bare concrete. So it's still vulnerable to some things like acid, right? And that's just something I want to bring up, because if you're trying to make acid-resistant concrete, you're going to have to go with a coating. And if you go with a coating, don't even think about polishing it, because your coatings may not stick. We're talking about bare polished concrete and the process of how to do that. So I just wanted to tie that in there, because it is, one of those things that you have to think about, and is a consideration when you're choosing to polish concrete. Another important requirement of your concrete is that it's dry, and this has to do with the chemical treatments that we do to the concrete. Now, when you first cast concrete, and you're mixing your concrete, whether it's in a bucket or in a mixer, and you're mixing water into it, your mixed water, what's important to realize is that water that you're adding is all the water your concrete ever needs forever. When you wet cure concrete, all you're doing is keeping that water that you put in the mixer in the concrete. You're not adding water to the concrete later on. You're keeping it from coming out. And when the water's in the concrete, especially early on, think of it more like a sponge or a bucket of wet sand. So your concrete, when it's brand new in the first few days, is mostly empty space, and that space is filled with water. And over time, as the the cement paste starts hydrating, as things start tying together, as you start forming the calcium silicate hydrate gel that becomes the glue, some of that water is consumed, and some of that water does evaporate. And the large open spaces gradually become smaller, and the microscopic capillaries that connect everything together gradually close up. They never fully disappear, but if you have concrete that's brand new, that's 2 or 3 or 5 days old, and you try to chemically treat it, the concrete's full of moisture, and it's got lots of space, which you need to fill up anyway, and you want to fill it up with the glue, the calcium silicate hydrate crystal glue that you're trying to grow during curing to tie everything together. You want to turn a weak solid into a strong solid. Well, you have to wait for that to really kick in, and 7 days is about the earliest point in time. 10 days would be better, 14 days is even better, before you even think about applying a chemical treatment. They're going to be a lot more effective later on, and I'll get into other reasons why later on. But if your concrete's full of water, you can't get a liquid to penetrate deeply into the concrete because there's already liquid there. And liquids are drawn into the concrete by capillary action. And so you have to wait for that concrete to first consume a lot of the water and then sort of dry out. And you don't want that drying action to happen too soon, because that also means your concrete stops curing. And if it stops curing too soon, it never gets strong. And so you're kind of defeating the whole purpose of getting strong concrete. You'll never get strong concrete. You'll never polish it well if you, again, try to do things too fast. So it's important for that concrete to get strong enough to cure well, to have its microscopic microstructure develop fully. And then once the concrete is strong enough and dense enough, you can allow it to start drying out, and you can allow that surface moisture to leave it. And really, we're only concerned with the upper few millimeters of concrete. We're not trying to densify or treat 10 or 30 millimeters into the concrete. We're really only looking at the surface few millimeters of concrete. So, it's not like we are trying to dry out the entire slab. We're just trying to dry out the surface. So if your concrete is 7 days old or 9 days old and you've done some wet processing on it, just let it dry out overnight, and then after that time you can do the chemical treatment, because they won't penetrate. If they don't penetrate, they're not effective. And I had touched on there's other reasons why we want to wait for that concrete to cure and to be more than 7 days old, is because one of the key ingredients that densifiers work on, one of the key elements that it needs, is calcium hydroxide. And as Portland cement cures, as it reacts with water, it starts generating your calcium silicate hydrate crystals that are the glue. But not all of the Portland cement turns into calcium silicate hydrate. About 15 to 20% turns into calcium hydroxide, and that's what makes concrete very alkaline. And the calcium hydroxide is what your pozzolans react with if you use pozzolans. And free calcium hydroxide is very reactive, and so densifiers consume that and react with that very, very readily. So you get the most reaction with your densifier when you have free calcium hydroxide in there. Again, brand new concrete doesn't have very much, so your densifiers don't have very much to work with. Even if you use pozzolans, you'll still generate some calcium hydroxide, and the densifiers will still work. They're just not going to work quite as quickly, but they still work. If you use calcium sulfoaluminate cements, the rapid hardening cements, they don't produce very much or any calcium hydroxide, so most densifiers don't react with them. They don't do anything. The only densifier that I'm going to talk about that will work with a CSA cement is a colloidal silica, because the free silica molecules will bond to other silicates, glass, stone themselves, the CSA cement. So they will harden and will densify CSA cements. So they're one of the densifiers that I'm going to talk about. They're one that I recommend using, and we'll get into that later. So I just want to make a further point of why it's important to let your concrete cure long enough. The other point to make about CSA cements is because they react so quickly, you're essentially getting 28-day strengths in 24 hours. It is possible to cast, strip, and polish a piece of CSA cement in 24 hours. And some of the pictures that I'm going to show you are of a piece of CSA cement-based concrete that was cast, stripped, and polished within a single day. They're unique. They're very different from Portland cements. You cannot do that with Portland cement-based concrete. You do have to wait a week or more. 2 weeks is better. And one of the samples that I show of a sort of a beige tan color concrete, it was cured for actually about a month before it was polished. And so you see a beautiful piece of concrete, and that's mainly due to the fact that I was patient. I waited. So that's another thing you have to consider when you're considering polishing concrete is, can you afford to wait that long? Now, what are the machines we're going to use? We're going to talk about the machines. We're going to talk about the pads. There's a whole host of machines that are not flooring machines. I have known people who do use floor machines on concrete countertops, and if you use a small floor machine on a large piece of concrete countertop, you can be quite successful doing that. However, there are lots of surfaces on a concrete countertop that you cannot use a floor machine. The vertical sides, inside a sinkhole, narrow sections, backsplashes, that sort of thing. So that's where these polishing machines come in. And they're all handheld units. Most are single head, and then there's some three-headed planetary machines, and they all use the same tooling. So for wet polishers, there are single-head electric and single-headed air polishers, and there's also an electric planetary polisher. In the photo here, there's the brand new Intertool DS3011, which can be run both wet and dry, so you can use wet pads and dry pads, which I'll touch on in a minute. And then for dry polishing, there are single-headed polishers that don't have a water feed. Some polishers, like the red flex in the top of the photo, top of the slide, is variable speed, so it can be used for both wet and dry, because dry polishing absolutely needs a variable speed polisher. And there are some planetary polishers that, like I said, the DS3011 can be run dry. Because it runs at a slightly slower speed, it doesn't necessarily need to have variable speed. And in my recommendations of polishing, it's not absolutely necessary to have a machine that goes very, very slow. I'm giving you a little bit of foreshadowing of what's coming up next. But I just want you to be aware that there's different types of machines, and they all give different results. So you cannot use wet polishing pads very effectively on a dry polishing machine, such as the green Metabo in the bottom of the photo, especially for coarse grinding. It's not what it was designed for. An air polisher, like the one in the top right, excellent for wet polishing. I have seen it used dry on stone polishing. Every tool has a certain sweet spot of what it does best. So if you have a variety of tools, you may have to find the tool that works best for you. There's no one tool that does everything equally well. There's always a little bit of overlap. So how do you use these things? Well, planetary polishers are easy. You put the pads on, and they all have to be the same pad, and they all have to start out new. So they all have to wear together. And you set it on the work, and you turn it on, and you just keep it from going over the edge. So a planetary polisher that's basically self-leveling, it's self-supporting, is very simple to use. So what I'm talking about here are the single-headed polishers that are handheld. They're essentially angle grinders, but they're used in a very different way than you would use, say, an angle grinder on metal or wood. Wet and dry polishers on concrete are always use flat, and they're never tilted up on the edge. If you do, you're going to gouge the work. The best way to make sure that polisher, the face of the polisher is always flat to the concrete, is you begin by turning the polisher off, setting it flat on the concrete so the pad is sitting exactly flat to the concrete, and then you turn it on. You never ever turn it on in the air and then set it down. Now, if it's a wet polisher, you want to turn your water on first before you set it down, and that's to prevent gouging from fiddling around with water and trying to adjust it, and then if you apply too much pressure to the back of the polisher or to one side, you could gouge the surface. So it's very important that you realize that the surface of the pad is going to cut into the concrete, and it's going to eat into the concrete no matter what the grit. And if that pad is crooked or tilted or there's more pressure on one side than the other, then you're going to actually dig a gouge into the concrete. So it's very important for it to stay flat. It's also important to keep that polisher moving at a steady pace and move it in an even pattern over the concrete. It's not like mowing your lawn where the wheel's right on the ground and you set the blade height to a certain level and you can keep going over the same spot over the grass and eventually you're going to stop cutting. With a polisher, you just keep digging into the concrete. So if you favor one little spot, if you're trying to expose some aggregate in one spot, you're going to dig a ditch. You're going to make a little depression. And if you don't want that concrete to have an uneven surface, then you can't do that. You have to take down every square millimeter of that concrete evenly to maintain its flat surface. So it's very important to move in a very consistent, even pace and an even pattern. And the challenge that I see a lot of people face when they're using a polisher is they don't have a lot of good body control. It's very important to maintain control of that head, how you move your body, how you move your hands, and that's where practice comes in. And just being aware that you have to work your edges just as much as you work the middle. You have to work the left as much as the right, the back as much as the front. And finally, when you're done polishing or you need to change grits, to stop, lift the polisher off the work while it's still running, while the water's squirting out if it's a wet polisher. Lift it off the surface, then shut it off and shut your water off. If you try to fumble around with the switch or turn the water off while it's on the work, what's going to happen is it's going to gouge. And diamonds cut differently at different speeds, and what I've seen is somebody stop a wet polisher on a piece of work, and as the diamonds are spinning slower, they actually cut different, and they leave scratches, where when it was up to speed, it didn't leave any scratches. So the best thing to do is just lift it right off. In summary, start it on the work and lift it off the work to stop it. If you do that, you'll have a beautiful surface. If you don't do that, you're going to be chasing gouges, especially with the coarser grits. Now there's a whole all different forms of diamond tooling to use. There are diamond hand pads, there are metal bond turbo cups, there's resin polishing pads, there's electroplated pads, etc., etc. I'm not going to deal with hand pads, although they share similar grits to the resin polishing pads. I'm going to touch briefly on the metal bond turbo cups, but we're really focusing on the polishing pads, the dry and the wet. And in the bottom on the left are some dry polishing pads, on the right are some wet polishing pads. And part of what's kind of confusing the whole pad industry is some pads are made for granite, some pads are made for marble, some are made for stone, some are made for engineered quartz. There's some dry pads that look like wet pads. There's some wet pads that are made for hand polishers that also can be used on floor machines, etc., etc., etc. So I'll try to give you some guidance and also give you a source of where to find some good quality pads that you'll see the results of their work, because they are the pads that were used. So when you're picking pads, you want to look for a diamond pad. I'm mainly talking about the resin polishing pads that have a high concentration of diamonds. So if you buy a pad for $2 on eBay, it's going to have a handful of diamonds in it. You want a lot of diamonds because the diamonds are the cutting. They do the cut. They're the teeth. If you only have a couple teeth, you're not going to leave a good surface. It's going to take you a lot longer to do what you want it to do. And also, cheaper pads that have fewer diamonds probably also have lower grade diamonds. What you want in a good quality pad is to have all the diamonds be basically the same size. So if you're using a 400 grit diamond pad, all the diamonds are 400 grit. There's not a few 100 grit diamonds thrown in there, and there's not a whole bunch of 800 and 700 and 900 grit diamonds that are just bulking things up. Diamonds that are really small, or smaller than you expect them to be, don't do anything. diamonds that are too coarse than what you expect are going to leave scratches. And so a more expensive diamond pad has better grades of diamonds. So they're all the same size, and there are probably a lot more of them. So they're going to cut faster and leave a better surface. Certainly thick pads give you longer pad life. There are a lot of flooring pads that are 6, 8, 10 millimeters thick. They kind of look like a truck tire. They have good channels to eject the slurry. Sometimes when you're polishing, though, you're polishing curved surfaces, and those thick pads just don't flex enough. So you may want to invest in thin pads. Although the thin pads don't last as long, they're versatile because you can work both a flat surface and a curved surface. So and a good example of a curved surface would be, say, inside a sink, inside an integral sink or a concrete vessel sink, where you want to polish that surface. So if you're looking to invest in some diamond tooling, you're looking for some different diamond tooling, these are some of the considerations, and these are just very, very brief bullet points. We have a better selection guide of things to consider on our website, on the CCI website, of how to find and select the right kind of diamond tooling for you. I had mentioned the channel design. The actual blocks that contain the diamonds that touch the concrete, if you have a really big block and very narrow, skinny little channels around it, then what's going to happen is that big block with lots of diamonds is going to create a lot of cuttings, but there's no way for those cuttings to leave out from under the pad, and they're just going to sit there. They're going to act as a buffer, and so the cuttings and the slurry act as an abrasive, and they're going to wear out the pad. They're going to wear out the concrete. They're going to clog the pad. If you have, and that's all relative. So you can have very big diamond pads with the contact pads and very narrow channels, or you can have very small, lots of little tiny pads, but very, very tiny channels. That's just as bad, because a pad like that can clog very easily, and if it clogs, it's not going to cut the way you want it to. And then finally, you want a pad that's made out of the right kind of resin binder. A lot of flooring pads are very, very hard. They have to stand up to a lot of contact pressure, a lot of heat, and although they wear a lot better than a pad designed for hand use, they don't cut very well because the resin is too hard. And you tend to see these in the really thick truck tire looking pads that are really made for a floor machine that has a few hundred pounds of pressure for you, maybe even 200-300 kilos of weight put on the machine. You can't do that. You're only applying a few pounds or a few kilos of pressure to your polisher. So you need a pad that's really designed for hand use. And if you're dealing with dry pads, if the resin is too soft or you have too much friction, you can actually melt the pad and smear it onto the surface of the concrete, and that's called glazing. So either the pad glazes up and the diamonds don't wear, or the pad smears onto the concrete, neither of which are good. So these are some pads that I'm going to say it right now. I sell these, right? These are pads optimized for concrete. They're high-quality diamonds, very dense diamond concentration, very uniform gradation, flexible. They're about 6 millimeters thick when they're brand new, about 5 millimeters thick when they're brand new. And although they look a lot like just about every other pad on the market, they're really optimized for concrete. Not all pads are. Most pads are made for granite because the granite industry is much bigger, and pads that look like this are really designed for the granite industry, and those just don't work well on concrete. And pads made for engineered quartz, which has a resin-based binder, also don't work very well. The pad gradation and the resin, everything's optimized differently. So it's important to buy a pad that's designed for the material you're cutting. And any of you who do flooring, do polished concrete floors, understand how important it is to match the pad to the surface you're cutting, whether it's new soft concrete or hard old concrete. Same goes for here. Now, grit progression is important. Coarse diamonds are naturally going to leave coarse scratches, and the purpose of finer diamonds is to remove less material, but also to remove the scratches left by coarser grits. And then as we move through finer and finer grits, the surface becomes shiny, and we call that polishing. So I mentioned that in the beginning, and I'm going to mention it again because it's really a function of grit progression. You can't polish concrete with one grit. You can't expect an 800 grit pad to give you a shiny surface. Its job is to leave 800 grit scratches, and those scratches could be their purpose is to remove the scratches from the 400 grit, or it's simply just to wear the surface very, very slightly, which is basically saying the same thing. You can start at any grit you want. If you're trying to expose aggregate, you want to use a very coarse grit to be very aggressive, and so you're not wasting a lot of time. But if all you want to do is refine a cream surface and you want to polish a cream surface, then maybe you're starting at a 1500 grit or a 3000 grit cert pad, where all you're doing is smoothing the surface with very, very tiny diamonds. They're still scratching the surface, you just can't see the scratches. Now, I mentioned grinding and I mentioned exposed aggregate, so there's no formal definition of where grinding stops and honing begins, and where honing ends and polishing begins. It's different for floors. It's different in the granite industry. These are my loose definitions of grinding, honing, and polishing, and that comes from observing using this type of tooling with a hand machine on concrete countertops. So what I mean by grinding is I'm doing heavy cutting. I'm exposing aggregate. I'm doing heavy shaping, where I'm rough cutting, removing material. I'm trying to level the surface, and as you can see in the lower right-hand corner, my friend Terry is exposing aggregate on and this happens to be a cast-in-place surface where coarse limestone aggregate, beer bottles, coral, and shells are being exposed. And the photo in the middle is the ground surface after everything's been exposed. And that takes a lot of time. It's very aggressive. There's a lot of cuttings. It needs a very robust tool. And these tools generally are around a 30 grit diamond in a metal, sometimes they'll call metal bond wheels, where the diamonds are actually encased in a metal matrix. Sometimes they'll call turbo cups. The shape of the swirly patterns it alludes to that name. But there are other styles of metal bond wheels that are aggressive, vacuum brazed wheels, etc., etc. But these tools are meant to expose aggregate, to do heavy material removal. You're taking 2, 3, 4, 5, 10 millimeters of concrete off. Although if you have to take 10 millimeters of concrete off, that means you probably shouldn't have put 9 millimeters of concrete on. But they're capable of it. Very coarse, very aggressive, nasty looking scratches. But that's what grinding is. Now, honing is basically at the coarse grades, 50 grit to 200 grit. Often honing uses resin discs, so we go from a metal bond disc to a resin-based disc. A 50 grit is like really, really light grinding. You can do some aggregate exposure, very light aggregate exposure. You're not going to be exposing what you see in the photo. You're not going to be cutting through the bottom of a wine bottle. You're not going to be cutting through and exposing 3/4 inch or 19 millimeter aggregate. You're going to take the cream off. You're going to cut through some sand grains. Maybe with patience expose the peaks of some of those big pieces of aggregate. But honing is basically scratch removal. You're leveling that coarse ground surface, you're removing those scratches, or if you're just starting from a cast finish, you're taking the cream off, you're exposing the sand grains, maybe you're cutting deep into the sand grains, exposing just the peaks of some of the aggregates that are below. The surface is dead flat, it's dull, it's lifeless. You can see these scratches. At the 200 grit stage, the surface you can see, and in this photo on the right, that's a raw, dry 200 grit surface where you can see swirl marks and dull scratches, especially in that blue glass bottle bottom. That's what a 200 grit surface is. Outside of polishing, the other way to finish your concrete is with a topical coating. And if you're going to put a coating on your concrete like a urethane or an epoxy, you're going to stop at a 200 grit surface. There's no point. It's a waste of time, and you're actually affecting the bond of the coating to the concrete if you proceed beyond a 200 grit. So never ever polish concrete if you're going to put a coating on it. But if you're polishing your concrete and you're just making the surface shiny and still bare concrete, then maybe you started to 200 grit and just take the cream off and expose some sand grains. Maybe you started at 50 grit to cut through the cream, cut deeply into the sand grains, expose some of the peaks of the aggregate, and then you would proceed from a 50 to 100, from 100 to a 200, and you're left with at the end of the honing stage where you see a bare surface, you see pinholes, you see these minor little fine scratches that you can't even feel if you run your fingernail over them. That surface is right at the right stage for filling in those pinholes with grout, a cementatious grout, to make sure that surface is dense. You don't want any holes in the surface if you're going to polish, because holes don't polish and they always make the surface look duller. This is the stage where that happens. And honing, just like grinding, is best done wet. Trying to dry grind is very dusty. It's very hard to see what you're doing. It's also creates a lot of hazardous dust. Honing, again, it's best done wet. It's much faster. I'm going to get into the pros and cons of wet versus dry later on, but my strong recommendation is do this wet. Don't try to do it dry. Finally, polishing is the process of you're scratching the surface with smaller and smaller diamonds to make the surface smoother and smoother. And what you see there is bare polished concrete that's pigmented red. You start to develop sheen around the 400 to 800 grit pad. You just get the hints of a sheen at that point. And as you get finer and finer, you start to develop the color of the surface more and more. The surface becomes smoother and smoother. It becomes shinier and shinier. And this can be done both wet and dry. My recommendations later on involve both wet polishing and dry polishing for the best results. But polishing is, although you are removing material, the amount of material removed is very, very minute. Essentially, the cuttings that come out from under the pad are very, very fine. It barely colors the water if you're doing it wet. The cuttings that come out from under dry pads is just a very, very fine dust if you can even see it at all. Whereas with honing, I'm going to step backwards. When you hone, you're generating lots of cuttings. That's what's called slurry. That slurry it can be very abrasive, very rough, and there's a lot more of it because you're physically removing quite a bit of material. And this is what some of those surface characteristics look like. This is a piece of CSA cement-based concrete, so it's rapid hardening concrete. It's 2 days old. I had pigmented it brown just to give it some contrast, and it's got some sort of dark gray and black crushed quartz and crushed granite aggregate in it. So on the left photo is a 30 grit metal cup wheel that was used to grind and expose the aggregate, and it's very fast. This is all done wet, and you can see on the left-hand edge of the where it's really pale, those swirl marks. Left of those swirl marks where it's darker, that's the raw cast surface, untouched. That's a melamine texture, and everything to the right is the raw cut surface. I did not fill any pinholes, so you'll see them show up as dark spots. And if you can see my cursor, I'm going to point to one. There's one there. And there's one there, and there's some dark spots here. I try to dry off the concrete so you can see the true nature of the surface, and you can see the sheen development as the dry concrete becomes smoother and smoother. So this is, a rough, coarse, exposed surface. The next stage would be to smooth out and remove all those scratches with a 50 grit wet resin pad. So this is wet honing. You can still see some swirl marks from the 50 grit pad, but they're much, much smaller. The surface is smoother. You notice the color. You're starting to get a little bit of color coming out, but it's still very dull, very lifeless. There's a reference aggregate. This is a good one to just keep an eye on, this sort of oblong shape there. And as we proceed, I'm going to skip to the 200 grit, here's a 200 grit surface as sort of a close-up to show you how smooth it is. And this edge, you can see here's the ground exposed aggregate, and as I'm feathering towards the cement cream finish, this is the cast surface, so it's pure cement cream on the surface. If you can imagine, it's sort of a tapered incline cutting into the concrete. There's a zone right here. It's probably 3 or 4 millimeters wide of basically ultra fine aggregate particles, very fine sand, and the cream that's being honed. And then you start to pick up, this area right here is what I call a salt and pepper finish. It's just the sand grains. And as you get deeper and deeper, you're starting to pick up some of those, the tips of the aggregates. And then back here, some of these aggregates that's about 10 millimeters tip to tip, just to give you some scale. So most of this gravel is about a 10 millimeter gravel size with some smaller bits. So as we get shallower, if you think of this as a beach, this is a sand beach and that's the edge of the water. As you get deeper into the water, as the water gets deeper, as we cut deeper into the concrete, you start to see more and more. And so a 200 grit pad is aggressive enough to cut this cream, and it's certainly aggressive enough to remove the scratches from the 50. Well, actually, it's removing the scratches from the 100 grit that I didn't show you. But it's not really aggressive enough to cut and expose much more of the sand grains. So pretty much to get this exposed aggregate look, you need to use a very aggressive tool. To get the sand grain look, you need to use a less aggressive tool, a 50 grit. To cut into the cream and maybe just get the cream off and begin to see the beginnings of a salt and pepper finish, maybe you just need to use a 200 grit. So different grits give you different looks. And so what you're seeing is kind of a smorgasbord of different looks from different grinding, but the whole surface from this edge to the right is all processed with 200 grit, and that's what you're going to keep seeing. So we're going to skip the 400 grit, and we're going to move to the 800 grit. And here you can really see how the surface is getting smoother and smoother, and we're starting to pick up some shine. And so I've inclined the camera to take a picture and pick up the lights, the reflection of the lights off the surface. Notice the color difference. We're picking up more of the color of the concrete, but it's not really that vibrant. The sand grains, although that oblong piece, this one here is right here, so it's a slightly different spot. That's an 800 grit cream finish that's been honed. So I actually keep feathering back into the casts finish as I proceed with the finer and finer grits to show you the effects of polishing a non-aggregate exposed surface. But you can see how the sheen progresses, and it's even. And notice there's pinholes here, there's some here, there's some little pinholes around the aggregates that are microscopic that, had I grouted it, they would be filled and the surface would look shinier than it is. But because I didn't, all these pinholes give you some darker, duller spots that take away a lot of the shine. I'm going to show you what the 3000 grit looks like in a second. So the tooling you use, the grinders, the grinding, the honing, the polishing, that's the process to expose the aggregate, to give the concrete the look you want, to give it the sheen you want. But most concrete, especially Portland cement-based concrete, needs to have chemical treatment to further harden the cement paste so that when we do get to the final polishing stages, the 400 grit, the 800 grit, the 1500 grit, the 3000 grit, the cement paste itself, the softer binder that holds all those hard aggregates, so that can become smooth enough and to become shiny. And what you're seeing here is sort of the effects of using these chemical treatments called densifiers. So chemical densifiers are different kind of silicate and silica chemistries that are put onto the concrete. They soak into the concrete. They react with the concrete. They react with that calcium silicate hydrate to form more calcium silicate hydrate gel, and essentially harden the concrete, make it so it doesn't chip so easily, so it doesn't dust and fracture so easily under this polishing, so it fills in the microscopic capillaries and makes it less porous, and it gives the concrete the ability to be polished so it reflects more light. And although I'm not going to get into it, on polished concrete floors, and it's certainly possible with polished concrete countertops, to use a guard type densifier. These are the last stages of polishing a floor where it's a chemical densifier that also has a polymer It's almost like a coating, but it's a very microscopic coating that goes on, and it's like a hard, it's not wax, it's much, much harder than wax, but it helps give the surface a gloss and enhance the color. That's something that is mopped on and buffed, and that's not part of the polishing process. That doesn't make polished concrete. It's usually the last stages of polishing a floor. But the polishing process is everything before that, and that's what we're focusing on. So densification is the process of using a material that reacts with the silicate compounds and the calcium compounds in the concrete to permanently close up the microscopic pores and capillaries in the top layer of a concrete slab. And these silicate compounds react, like I said, with the calcium hydroxide that's available and other calcium compounds in the concrete. In the case of the colloidal silicates, it also bonds the silicates to deposit more and create more calcium silicate hydrate crystals. So in essence, you're filling the concrete from the bottom up. You're treating it from the inside out. Unlike coatings, which are from the outside and they don't really penetrate in. These are true penetrating treatments that get in there, they change the concrete, they improve it, and these are permanent. Like I said, they generate more calcium silicate hydrate gel, and they only do that in the presence of calcium hydroxide. So most densifiers only work with Portland cement that's well cured. And just to summarize, it hardens the cement paste so that cement paste doesn't crumble, it doesn't wear away very easily, it can be polished to a high shine. The densifiers plug the capillaries and eliminate the capillary draw that sucks moisture into the concrete, fills in some of those micropores to where it makes the concrete less porous, to the point where you can actually get water to bead up on the surface of concrete. And then it also helps to fill in some of the non-visible microscopic scratches on the surface, so it helps to improve the look of a polished surface. Although if you have untreated concrete and you polish it to, say, 3,000 grit and then you put a densifier on it, it's still going to look the same. That's not how they work. They're not meant to fill in scratches that you can see. They're there to help improve the polishing process. So they're part of the polishing process, and that's why they're so important. Now, there are lots of different kinds of densifiers on the market, and there's lots of different choices. So which do you use, and which do you avoid, and what do they do, and which is better, and what goes first, and can you use more than one? Well, I'm going to address all that. And the three basic categories, the basic types, they're siliconates, they're silicates, and they're silica, and they're different. They behave differently, they do different things, they are not interchangeable, but you can use them in sequence. So we're going to start with the siliconates. These are the biggest molecules. So if you think of a siliconate as being something the size of, say, and I'm exaggerating here, a bowling ball, right? Something big. These are big molecules. They're sodium siliconates and potassium siliconates, and it depends on where you are and who you buy it from. The sodium, the potassium part is just the stabilizer and the carrier that makes the siliconate be chemically available in liquid. They stay in the bottle. They're good for years. And when you put them on concrete, the concrete soaks into the concrete and starts reacting. So these are very high pH liquids. High pH is very alkaline, and high alkalinity liquids react much faster with calcium hydroxide and some of the silicates in the concrete than a lower pH, so that these tend to be faster reacting. If you put too much on them and they pool and then dry, they can cause whitening on the surface, so it's important to not over-apply them. Every manufacturer gives you the right application instructions, and I'm going to show you how to do them. They're very, very easy. What you see here is one of my favorites. Is a product made by V-Seal called V-Seal 101. It's a potassium siliconate. It's relatively inexpensive. I've had a bottle sit on the shelf for a few years. This is not a hardener. It's not a densifier, but it's considered to be used as a densifier because it functions as a pore filler. It's that big molecule gets in there, and it plugs a lot of the big capillaries, plugs a lot of the microscopic pores. And its real purpose in the commercial world is to seal, say, parking decks and bridge decks and and driveways and sidewalks. It keeps salt from getting down into the concrete. It keeps liquids from getting down in the concrete. You can see the photo of a piece of polished concrete that I did. That's water sitting on bare concrete treated with VCO-101 and potassium siliconate. Its function is to fill the holes and give a good base for your smaller densifiers, and it's also to provide water beating action. And there are products that are both a siliconate and a silicate blended together, so you get the best of both worlds. So silicates, they're the most common. There's a lot of different kinds. There's the oldest and the least expensive are sodium silicates, and also they're potassium silicates. Like the siliconates, these are high pH, they react really fast. The sodium and potassium are leftover carriers, and those react with the calcium hydroxide. Now, calcium hydroxide in concrete is a byproduct of the chemical reaction of your cement paste curing. That's what you want, right? Well, the calcium hydroxide is left over, and it doesn't contribute to strength. It's a weak, big crystal that takes up space. It likes to form on the surface of your aggregates, and it prevents the calcium silicate hydrates from fully bonding to the concrete. That's why you can get better improvement by using pozzolans, because they consume that calcium hydroxide and form more of that gel. Well, so do silicates to some degree. But because silicates only affect the top surface, they're not treating the entire mass of the concrete. They're only treating the top few millimeters of the concrete. But getting back to the sodium potassium silicates, they can cause whitening if not applied, because the residue that's left over is sodium hydroxide or potassium hydroxide. Very caustic, kind of nasty stuff, and it's very difficult to rinse off. You have to scrub it off. So these are not a good choice to use. They're better silicates to use, so don't use a potassium silicate, don't use a sodium silicate. They're cheap, but there are better choices out there. The concrete flooring industry is all about being efficient, being effective, and being cost aware. And so they're focused mainly on lithium silicates. Now, lithium compounds were originally developed to protect concrete from the alkali-silica reaction that can happen if you have glass in concrete and it gets wet, or reactive aggregates that are in concrete. And so these lithium compounds would be sprayed onto concrete to help protect, say, a road that has that. But the nice thing about lithium silicates is they also are a very effective densifier. They're a true densifier, true hardener. The silicate reacts quickly. It's a small molecule, so it penetrates fairly deeply. It's not such a high pH, so it's a faster reaction, but because it doesn't react very, very quickly, you get a deeper penetration. You may get 5, 6, 8 millimeters, depending on your concrete. It's kind of like case hardening steel, where you're improving the surface to get better results. Lithium silicates generally don't cause whitening because they soak in so easily. This is the primary densifier of choice. And this product, VCO Industrial 117A, is actually a siliconate and silicate blend. So it's a really nice standalone single densifier if you were going to only use one. And finally, the newest are colloidal silicas. Now, siliconates and silicates are actually chemical compounds. So they have a sodium or a lithium or potassium part that helps stabilize and create a solution, a dissolved solution. Just like if you take sugar or salt and you put it in a glass of water, the sugar dissolves in the water. You have a solution. The lithium silicates and the potassium silicates and the potassium siliconates, those are all solutions. Colloidal silicas are not solutions. They are kind of like if you've ever made a cup of tea and you use loose tea. The tea leaves, if you stir it around, the tea leaves are still tea leaves and they're floating around inside the water. That's a suspension, not a solution. Colloidal silicas are suspensions of nanometer-sized silica particles that have been chemically made active. So they're ready to latch on and start reacting, but they're a suspension. Because there's no stabilizing element, almost all of what you have in that bottle is reactive. So you're kind of getting more for your money. They're lower pH, so they penetrate fast, deeply. Because they're so much, they're just pure silica, they're very fast reacting. So you get deep penetration and quick reaction. I have noticed on some of these, though, on new concrete, what happens is they react so fastly they turn into a gel. And that gel, you have to add water to it to dilute it. And if that gel dries, it will whiten. But when properly used on well-cured concrete, they penetrate deeply and don't leave a whitening agent. And because there's no residue, there's no sodium hydroxide residue, there's no potassium hydroxide residue, there's no rinsing needed. So these are becoming more popular in the polishing world because you put them on and they do their job, and they do their job quickly. The other big advantage is they will work with CSA cements because they don't rely only on calcium hydroxide to work. The downside of colloidal silicas is that they're a very small molecule. So if the potassium siliconate that I mentioned first was like the size of a bowling ball, the lithium silicates are more like tennis balls and golf balls. And colloidal silicas are kind of like BBs or tiny ball bearings or even sand-sized grain particles. They're very, very small. So if you're trying to fill a hole, it makes sense to fill it with something big first and then fill the spaces between the big stuff with smaller things and then fill the spaces between the smaller things with even smaller things. And that's the approach that a lot of folks take, is they fill the concrete first with a siliconate, then with a lithium silicate, and then finally a colloidal silica in that sequence. Because if you try to fill a hole with tiny sand, you need a lot of it, and all you're doing is coating the surface. You're not actually filling it up. So it's much more effective to use a bigger molecule first and then finish off with something small. Some misconceptions about densifiers is that they fix poor concrete. And by poor concrete, I mean your typical home center 5,000 psi bag concrete mix that you mix in a wheelbarrow and you're just dumping water with a hose and you're kind of doing everything by eye and you have no idea what your water cement ratio is. That's junk concrete that's never going to get improved, and densifiers can't fix that. Another misconception is that you can fill in pinholes and scratches with a densifier, that you can pour it on and it's somehow going to fill the holes. Another misconception is that they work instantly. Although they're fast, they generally are best. They take a few hours or even overnight to work properly. And then the last two misconceptions, and this has to do with the general observation of polished concrete as being smooth and shiny, is that somehow densification seals the concrete and gives it stain protection. It's true that well-densified concrete doesn't absorb moisture very quickly. So you can pour water on it and it beads up. And if, let's say, you spilled coffee on it or something that wasn't very corrosive, you're going to leave a mark on the surface. That mark might be able to, you can wipe it up very easily, which is water, or maybe just bleach will take out the surface stain. But the biggest misconception is that it somehow makes concrete acid resistant. So if you took well-densified polished concrete and you spilled vinegar on it, that vinegar is just going to sit there and eat the concrete because it's still bare concrete. Because all densifiers do is make more of the same thing that is the glue that the cement makes, and that's the calcium silicate hydrate crystals. And the other thing to remember is that even though water beads up, it's still touching the surface. So that vinegar or that red wine or that lemon juice is physically touching the surface, and if it's touching it, it's chemically reacting with it. And when it does that, it etches the surface, and then you get this chemical damage to the surface. So densifiers, they might slow it down a little bit, but they're not going to stop it. Now, when do you do these? When do you use these? We talked about the polishing process, the grinding process, the honing process. And because densifiers only treat the top surface of the concrete, and they really are there to benefit the polishing process, apply them only after, if you're going to do grinding, you're done with the grinding. If you're going to fill in pinholes, you're going to do the grouting, you're going to hone it off. If you're going to do any honing, that's going to be done. And once all your concrete has been ground and honed, or honed and grouted and filled and smoothed, and you're done doing any kind of physical, mechanical stuff to the concrete, let it dry. Typically overnight's good enough, and then you apply the densifier. If you apply the densifier before you grouted, you're not going to give the grout the benefit of, you're not going to get the benefit of the grout. Pardon the pun. The densifier should work on the grout too, because that's a cement-based compound. Grout it, hone the grout off, get all those pinholes filled, then densify, and I usually densify more than once, 2, 3, 4 times, just to make sure that that concrete is really tight, and then I go through the polishing process. Once you get past the 200 grit, you're taking off so little material, you don't have to worry about removing that densified layer. But if you densify and then grind, not only is the grinding going to be harder to do, you're going to take away most of the densification anyway, so it's pointless to do it then. Now, if you're going to be applying a coating, let's say you're going to be doing Stonelock E32K, which is a water-based epoxy with a water-based urethane, and I talk a lot about that on my website. Should you apply a densifier at the 200 grit stage? I get this question quite a bit, and the answer to that is I don't know. The risk is, if you do densify, is that densifiers, their job is to make the concrete less porous, and the risk is you make the concrete too microscopically smooth and non-porous, so your coating won't stick. The jury's still out whether you should do that or not. Some densifiers, like the VCL 101, which is a potassium siliconate, its job is to plug the holes. So yes, you can apply that and then put a coating over it. Others, not so sure about, especially the sodium and potassium silicas that generate all that calcium silicate, sodium hydroxide that can contaminate and actually cause problems with your sealer. So if I had to be absolute, but you're not going to want to use those anyway, if I had to give you the advice, I'd say don't do it. If you are going to do it, test it on samples to make sure that you don't lose adhesion. So it's kind of a gray area. But generally the job of a coating is to provide all the protection, and not, in a densifier, its job is to make the concrete hard enough so it can be polished, and also to prevent liquids from getting drawn in. Of course, your coating should be doing that for you, so you don't need it. So here's the process of putting it on. Every densifier manufacturer has instructions, and they might vary a little bit, but this is the basic gist of it. You're trying to saturate the surface of the concrete with a densifier, so it has to start out dry, because if it's got water in it, the densifier is not going to be drawn into the concrete where you want it to be. You soak the concrete to saturate it, which means it sits or dwells on the surface for 10, 15, 20 minutes. When you first start densifying concrete, it just soaks it up like a sponge. And you keep putting more and more on until it stops getting drawn in. And so the concrete's going to tell you when it's saturated. But what's important is you've got to keep that surface wet. Never let it dry out. So if you have concrete that has basically stopped drawing it in after, say, 10 minutes, you'll still want to let it react and stay wet so it can keep actually doing its reaction. Just spritz it with some water. Just add some plain tap water in a spray bottle just to keep that surface wet. If the densifier is on the surface and it really starts to gel up, all of a sudden it goes from a watery liquid to this thicker gel on the surface, what that's saying is that the concrete's drawing the moisture out of, it's reacting with, but also drawing the moisture out of that that densifier, and what you need to do is add more moisture to it. So spray it with some water, get it nice and liquid again, rub it around with a stiff brush or a cloth, or I like to use those like green Scotch-Brite pads just to spread it around and work that gel into the surface, get it to be more of a liquid again so it can soak in. After the concrete basically stays wet and doesn't really change its appearance, it doesn't get dull really fast. Once it stays pretty much the same for a good minute or two, it's pretty much saturated and you're done. So what I like to do is I'll take some paper towels or a clean cloth and wipe up any excess densifier that's on the surface, because it doesn't do any good to be on the surface, and that prevents it from getting crusty and dry and wet and white, leaving white residue. So you wipe up the excess. Don't rinse it, just wipe it up, let it dry, and give it time to react. Give it a couple hours, give it 4 hours, give it 8 hours, let it sit overnight. The more you let that densifier work, the better off you're going to be. And if you're going to do this like I do in stages, I'll densify and let it sit a couple hours, and then densify it again and let it sit a couple hours. And so each stage has time to do its thing. If you're only densifying once, by all means, soak it in and let it sit overnight. If you start polishing too soon, the densifier hasn't done its job yet, and so you're actually shortchanging yourself. Patience is the key with polishing. I'm sorry to say. It takes time. So here's what it looks like. This is a concrete cafe table I made. I'm using VCO 101, it's a potassium siliconate, and this is to get that beading action. And so I just pour it into a bucket and put it on. I'm using a common household sponge, and the sponge is saturated, it's soaked with the densifier, and I'm just spreading it on. You can spray it on with a sprayer, a little hand sprayer, a little pump-up sprayer. You can pour it on and spread it around. You can use a brush, you can use a cloth, it doesn't matter. You want to spread that material out evenly so that that surface stays wet. And you can see in the right-hand upper photo how some areas are starting to soak in and they start to get dull. That's a sign that the concrete's drawing that densifier in, and you need to add more. Because you do not want to let those dry areas that don't have enough densifier on them, you don't want that to dry out, because if it dries out, it's going to kind of plug the surface and you're not going to get the material in the concrete where you want it. The lower left-hand corner, you see how it's dark and shiny, kind of even looking. That's what it looks like when the concrete's fully saturated. It's basically done absorbing. You can keep adding more, but it doesn't soak in. And now is the time to wipe it off, let it dry out, and then the next day, put water on it, and there it beads up. So you can see the sequence. It's very simple. Generally, it's a process I call babysitting, and small projects like this, if you're only doing one table, it's kind of tedious because it only takes a few seconds to spread it around, and then you have to wait, and then you might have to put more on in a couple minutes, and then you're standing around waiting. If you got a bigger project, a real project, you kind of work from one end. By the time you get done to the other end, it's time to go back to the beginning and keep going. So it's actually easier to densify a bigger project. You just basically don't stop. But little projects, you have to be careful. If you walk away for too long, it's easy to let things start drying out, and then it's not so good. I mentioned this earlier, and here's sort of the slide that summarizes it. Use your hardeners in a sequence. You don't have to use all of these, but you're going to get the best results by using these in the sequence. You start with a big molecule, your siliconates first. Then once those are put on, let it react overnight. Then you do your lithium silicates to densify and fill in those spaces. They actually start to harden the concrete. That densifier, the 117A that I showed you, is a blend, so it's basically doing both steps at the same time. So it's a time-saving factor, which is quite beneficial. And then the colloidal silicates, although you can add them in sequence right after the lithium silicates, they tend to be best when added later on in the process because they're so small, and they either penetrate very deeply, and it's to keep them near the surface where they do the most good, you have to wait for that concrete to become less porous so they don't penetrate too far, and you're getting the best effects later on. All this is done after you're finished honing with the 200 grit. So generally, before you do the 400 grit pad is when you densify. Although you can densify after the 800 grit, you can densify after the 1500 grit. I've even densified after the 3000 grit, but it's best to do it early on because that's where you're going to get the most benefits. Now, the polishing process, which is a bigger scope, has some steps that happen before you densify and some steps that happen after. So the pre-densification steps generally occur once your concrete is hard enough to strip from the mold, and sometimes some of this gets done before it's fully 7-day cure. A lot of times it's done between the 3 and 7 day steps, but that includes your grinding, wet honing, you're grouting your pinholes and voids. If you're doing a variegated surface or a hand press surface where you have veins and fissures you're creating, you're doing multiple grouts in different colors at different times. You need to let all that grout to harden up, hone it off to 200 grit, let it dry, and then you move on to the next stage, which is your densification steps. So you do your densification, which we just talked about. You let that densifier do its thing, sit overnight. Again, all this happens after the concrete's cured for at least 7 days. So some of it can occur before 7 days and before densification, but densification is best done after 7 days, after the 200 grit stage, and before most of the polishing or all the polishing begins. So you densify, let it sit overnight, and then we begin with the mechanical process of making the concrete smoother and shinier through polishing. And my strong recommendation is you do all your polishing, especially in the coarser grit polishing stages, do it all wet. 400 grit wet, 800 grit wet, 1500 grit wet. I've even done 3000 grit wet. You get a better results. I'll talk more about that in a minute. You let the concrete dry. Again, overnight's best. Apply a colloidal silica, very different. There's no such thing as a colloidal silicate. They're colloidal silicas. Apply that. Because they react fast, you might only have to wait 15 minutes, 30 minutes, and then begin the dry polishing stage. So you switch from wet polishing to dry polishing. And I like to, even if I wet polish to 3000 grit, I back up and I dry polish to 1500 grit and then proceed to 3000 grit. I'm going to talk about why that's done and how it all works and why you get a better sheen dry polishing than you do wet. But the gist of it is you get a better polish when you finish dry. And that's what a finished polished densified concrete surface looks like. High sheen, very smooth, pour water on it, beads up, very, very durable surface. So I mentioned the differences between wet and dry and why you want to do some wet and some dry, and what are the benefits, what are the pros, and what are the cons. Well, wet polishing, I'm a big fan of wet polishing. It's much faster, 5 to 30 times faster. There's no dust, and because you can be wet processing, and I mean grinding and honing, you can be wet grinding and honing concrete that's only a few days old. That's going to assist in your wet curing because you don't want to let your concrete dry out early on. You continue the wet curing process, you keep that moisture in the concrete where it's reacting, forming stronger concrete, forming tighter, less porous concrete. If you're using high-quality diamond tooling and you know how to use your polisher, you'll have few or no scratches at all. And you have a lot more tooling choices. You have a lot more machines you can choose from. You have a lot more diamond pad selection. You have different sizes that are possible. There are 3-inch, 4-inch, 5-inch, and 7-inch pads. So the versatility of wet polishing is very, very beneficial. That's why it's so appealing. Here I'm polishing a large GFRC tabletop that has embedded glass, and that table was 2 months old when I started polishing it. So it encapsulates all the things I've been talking about. Is you start with good concrete, low water cement ratio, it's well cured, it's dry. Well, it's not dry because I'm wet polishing it. Excuse me, but the end result is quite spectacular, and you've already seen a picture of that earlier on. The cons, the downsides of wet polishing, well, the big one is it's messy. You have a lot of water. There's a lot of cuttings. And you have to have a water source. And if you're dealing with electric polishers, you have to deal with water and electricity. So either the machines come with a ground fault circuit interrupter, GFCI, as they're called here in the United States, or you have one somewhere upstream in the electrical circuit, so you're not shocked and you don't kill yourself. I've been wet polishing for almost 15 years, and although you occasionally get a tingle with some machines, I've never been shocked enough to actually get hurt. It's not pleasant, and that's why I wear rubber gloves usually. But it's something to consider. Air polishers, they don't have electricity, so I've actually air polished underwater. That's one of the big benefits of an air polisher, which generally are done wet, but I've seen them done dry. The other con of wet polishing is it saturates the concrete pores. So you're pumping water into the concrete, and you have to give it time for that moisture in the surface pores to evaporate out. And then finally, wet polishing, even up to a 3000 grit, tends to yield a slightly duller surface than if you had done a 3000 grit dry polish. And it's not obvious why, but I'm going to I'll tell you why in a little while. Okay, so I think the downsides of wet polishing are outweighed by the huge benefits of wet polishing, especially the fact that it's fast and you get such a good quality surface. And I'm going to show you what the difference between wet polishing and dry polishing the same piece of concrete looks like. So, dry polishing. Why would you do dry polishing? Well, you get a better shine, especially at the final last couple grits, like 3000 grit. It's easier to see what you're doing because you don't have this water and all these slurry cuttings obscuring your view. The friction between the dry pad and the surface, frictions help densifiers. Chemical reactions work better at higher temperatures, and you can get the temperature of the concrete to be quite hot, almost too hot to touch. Here in this photo, it was at a granite polishing event where there's a pneumatic polisher either dry grinding or dry polishing the edge of a granite slab. He should be wearing a dust mask. He's not, but he should be. Because dry polishing is less aggressive, it's part of the reason why you get a better shine. But as part of the downside, it is they're very slow. Trying to achieve a 50 grit exposed sand grain surface with a dry polishing pad on very hard, well-cured concrete can take ages, where it can take moments with a wet polisher. So it's very slow, very inefficient at coarser grits. Because there's nothing to flush the cuttings out from under the pad. You're merely allowing for centrifugal action to fling the dry cuttings out from under the pad. The likelihood of scratches in the surface and premature wear in the pad is much greater. You have to use a variable speed polisher. A single speed polisher just doesn't work, especially at coarser grits, because you have to feather the speed of the pad depending on the grit you're using and the hardness of the concrete and the hardness of the aggregates. If you go too fast, if you run the discs too fast, what happens is you get so much friction, the resin that holds everything together softens and it actually starts melting. And when it melts, it smears resin into the concrete, and it also lets diamonds tear out from in the pad. And then if a whole diamond gets torn out of the pad, it just tumbles around on the surface, and you see a huge scratch. And I'll show you a picture of what that looks like later on. Now, if you run the disc too slow, well, not only are you cutting very slowly and very inefficiently, the cuttings just don't get flung out. They just stay under the pad, and so they form a cushion, and it starts chewing up the surface of the concrete, but not in a good way, and it also starts wearing out the pad. So finding the right speed requires a lot of skill, and that's why a variable speed polisher is necessary, and it takes more practice to dry polish well. It's easy to dry polish, it's hard to do it well, so you don't see scratches. And the biggest downside of dry polishing is it generates a lot of very fine crystalline silicate dust, which is very hazardous. You have to use a HEPA vacuum. such as this dustless. This is probably the least expensive HEPA vacuum you can buy. You should also be using a dust mask, not a nuisance mask, but one that's actually designed to filter out fine particles. And the least effective one is in the U.S. is called an N95. It filters out 95% of the microscopic dust. There are N100s that filter out nearly all of it. Your dry polisher should have a shroud that collects the dust at the surface. Dustless makes shrouds that fit on almost all polishers. So I have one that fits on my electric polisher, and that way I'm able to capture the dust as it's being generated, and it's sucked into a vacuum where it's filtered out and it's not getting blown into the air. And if there is any that does escape the vacuum, my dust mask protects my lungs. Because once silicate dust gets in your lungs, it's there forever, and that's what silicosis comes from. Nasty, nasty stuff. And that's one of the big reasons why I prefer wet polishing, wet processing, is there's so much less dust, or there's no dust produced at all. And I save the last stages, the dry polishing, which produces very small amounts of dust for the dry stages. Here you're looking at the same piece of concrete. Two ends of a sample that I made. On one end, I wet polished to 800 grit, and what you're seeing is I started with an as-cast finish. I just wet cast concrete onto a piece of melamine, vibrated it, and when I stripped the concrete off, or the concrete from the forms from the concrete, I immediately went with an 800 grit wet pad to the cream. And you can see how it was pretty aggressive, and this is about less than 30 seconds worth of honing. The area, the size of the image you're seeing is roughly, it's a slight close-up, but it's probably 75 to 100 millimeters square. So depending on your screen, it might be life-size. That whole area to hone it to that degree only took a few seconds. Very fast. And notice how there's no scratches in that surface. It's extremely even. The little hints of shine you see in the center are the sand grains being honed. And because this is a fairly new piece of concrete, it's only a few days old, and it was not densified, the cement cream is still soft, and that's why it looks dull. On the right is the same piece of concrete, it's the other end of the sample, that I started out dry polishing. I started with a 400 grit, and then I went to an 800 grit. Because the 800 grit just skated over the top. Melamine has a slight texture to it, and the 800 grit was it was basically burnishing the high spots and not actually removing the texture. So I had to switch to a 400 grit just to get down to below the bottom of the melamine texture, and I'm still within the cement cream. And there are several things to see. In fact, you can kind of see in the center, where's my cursor? See all those dark spots, that sort of dark texture? That's the melamine texture that hasn't been completely removed. So here I'm down to the sand grains. I'm at the tips of the sand grains, so there's almost no cream left, and that's only a few seconds. What you're seeing is about 20 minutes worth of dry polishing to get to this stage. Well, I'm exaggerating it. I mean, it's, I was going back and forth, but it's several minutes worth of dry polishing at 400, then 800 grit just to get to the stage. And here's one of the big downsides of dry polishing, especially trying to dry polish new concrete that's not densified in a cream finish, is you get lots and lots of surface scratches that you cannot remove because you keep making new ones. So see all these swirl marks and these scratches? That's when I said I was working for 20 minutes. I was trying to get those out, and I kept making new ones. The surface is just far too soft for a dry polishing pad to be effective. Dry polishing pads are most effective on very hard glass and stone. The harder Mohs hardness, the 5.5, 6, 7, 8 on the scale. Quartz is 7. This cream finish is probably like a 3. You certainly can't scratch it with your thumbnail, but it's clearly too soft to take a polish. And what's happening is the scratches come from some of the diamonds getting pulled out. All the cuttings that are generated stick to the resin. They kind of it tumbles around in between the surface, and that's where these scratches are come from. And the friction softens the pad, so some of the diamonds stick out more and gouge, and was an exercise in frustration. So I wanted to show you this huge difference in surface texture you get when you try to use a coarser polishing grit. 800 grit is a pretty coarse polishing grit. You're not really getting a high shine. And the reason why you see more shine here than you do here is the burnishing effect of all the cuttings that tumble around. They break down and they actually act as finer grit. So you get a thin layer of dust that does the polishing for you. But then you have all these coarser diamonds that are there to leave big scratches. So you can't have the best of both worlds. And that's the secret to why dry polishing at, say, 3000 grit gives you such a high shine. It's the cuttings that are actually giving the shine, not necessarily the diamonds. The diamonds are there to kind of generate the cuttings, but then you build up a thick enough layer of cuttings to actually do burnishing without leaving scratches, you hope. Let me take a deep breath. Another example. There's that same piece of CSA-based concrete that I had pigmented sort of brownish. We were seeing the different effects of grinding and honing the coarse aggregate, and this is the cream section. So way down at the bottom here is the as-cast melamine surface that has not been touched at all. So that's what it looks like out of the form. See how it's a little bit lighter here and here? And this whole surface up to here has been wet polished. So I started wet grinding, and this is the same sample. This is the left side, and that's the right side. That red line, that red vertical line is sort of the dividing line. And I wet polished this side, and then I wet honed, wet polished, and then finished up with dry polishing on this side to show you the differences. Now there's not a whole lot of difference in sheen at the coarse aggregate side, but when you are dealing with a very fine salt and pepper finish, or even a cream finish, you see more of the burnishing effects and the benefits of dry polishing down here. See how this side's darker than this side? This side here is all of this side. And it's the fine dust that's generated that burnishes that cement paste. To give you an idea of the strength of this concrete, although it's only a couple days old, it's CSA-based concrete, so it's 10 to 12,000 psi concrete at 2 days. Translate that into metric, you're looking at 80 to 90 MPa concrete at 2 days. Very, very hard. Takes a polish very nicely. And the differences in polishing a very hard cream surface, you get more benefit with dry polishing than you do wet. If you're not doing that, if you're only exposing aggregate, you basically get the same results, dry and wet, so you can almost skip the dry polishing stages and just do everything wet up there. But I just wanted to point out that if you're looking to polish a cream finish, make sure it's very, very hard, very well cured. You get your full strength, densify the heck out of it, and then you're going to get the best results by finishing with a dry polish. And there's the visual evidence right there. So to summarize, wet polishing gives you a slightly duller surface in cream finishes. You're not really going to see much difference in a heavy exposed aggregate where your aggregates can take a shine quite nicely. Your coarser grits, certainly your 100, 200, 400 grit, you get a much, much better surface quality. Even the 800 grit, you get a much better surface quality, fewer or no scratches doing it wet than doing it dry. Because it's wet, you can spin the tools faster. Diamonds don't cut unless they're moving, so the faster your diamonds move, the faster you're cutting. It's more effective, more efficient. The water that's squirting out through the center of the pad and flushing the cuttings cools the pad, so there's no friction melting, there's no burnishing. Those cuttings are flushed. They don't have time to break down, so they not only do the cuttings burnish the surface, but they also pack into the surface pores. And that's sometimes relied on in polishing concrete floors, is they'll put down a densifier, and while it's still damp, they come in and they do a dry polish on it, and that damp densifier and the cuttings kind of pack down into the pores to help fill it, make the surface shiny. The upside of that is you get a really shiny surface. The downside is depending on the densifier, that could wash out or wear off, or because part of the pad wears away too, those cuttings are a different color depending on the color of the pad. So if your pad's like a dark brown, all of a sudden the cuttings become dark brown. And if you're trying to dry polish white concrete and you don't get the pad residue out of that packed dust that's in the surface, your concrete doesn't look white anymore. You have to clean that off. And there's different ways to do that. I like to just wipe it down with acetone. That gets it off. But you don't have that with wet polishing because the water flushes all that away. It's not an issue. And then finally, to get that final shine is just hit it with a hog's hair pad. And these are floor pads that are made out of, well, hair. There are different kinds of pads. It's a common floor burnishing pad. It's not abrasive, but what it does is it helps lift some of the dust and help pick up a little bit of that dust and use that as the final buffing compound. It's almost like a compound, the fine residue of that's still stuck to the surface. It helps to do a final polish. So that's the sheen from a 3000 grit wet polish, and then that's the same sheen with a hog's hair buffing pad. And although it's hard to see side by side, you do see a little bit of an improvement, and that's what a hog's hair pad looks like. They don't have any diamonds in them at all. They just kind of rely on the material itself to provide the abrasive. Now with dry polishing, the summary of dry polishing is you do get a higher gloss when you finish your polish dry. And that's most noticeable in the cement cream finishes or in a very light cement cream finish, or a salt and pepper finish, where there's no coarse aggregate exposed, just a fine sand and a lot of cement paste. The pad friction creates heat, and that helps to soften the resin. That resin grabs onto some of that dust, holding it to help burnish the surface. The downside is that heat, if there's too much, you push too hard, you spin too fast, you lean too much on one side, you get too much heat, pad softens too much, a diamond grabs, tears out, and all of a sudden you got this huge boulder of a diamond churning around between the pad and the surface, and you create huge gouges. Because there's no flushing action, there's no water, there's no air blowing the cuttings out, they stay under the surface. The fine cuttings get packed into the surface. They act as that burnishing agent, that fine, ultra-fine polishing powder that gives it that final shine. And so you can achieve very, very high gloss. This is that piece of concrete that was a couple months old when I polished it. So I ground the left side wet, and then I honed everything wet, 50 grit, 100 grit, 200 grit, 400 grit, 800 grit, 1500 grit, and then I switched to 1500 grit dry after densifying. I densified around, in this case I actually densified after about 400 grit because I had to grout some of the pinholes, and then I finished dry. I finished 3000 grit dry, so you get this very high reflective surface. You can see the quality of you can see the reflection of the fluorescent tube is much better defined because the surface is smoother. There's fewer pits. It's more even, and that's the hallmark of a high quality surface. And I mentioned the downsides. Just a quick summary: if your concrete is not super hard, only hard polish surfaces polish well. If you have a cement cream finish, if you have young concrete, you're going to chew up the surface. It's going to scratch very easily. You're going to erode your cement cream. You're actually going to have a profile where the hard aggregate sticks up above the surface. Your grout, if it's not hard enough, is going to erode and actually dish out. That's why the densifiers are also important. It helps to harden that cement cream. Dry polishing is not easy. It's not something you just pick up and start doing. You've got to practice because how hard you push on the polisher, the size of the pad, the speed you're spinning it at. Typically they're running around 1,000 to 1,200 RPM, but sometimes you go faster. You have to look at the concrete and I call it reading the concrete, see what you're doing. If you're getting a lot of scratches, you're going too fast, or you're pushing too hard, or both. Or your concrete's too soft and you're creating lots of grit and you're pulling out diamonds. So there's all different things that can lead to a bad quality finish. And sometimes it can be frustrating because you could be really good at polishing and you can be really good at wet polishing. But when you go to dry polish and you start trying to dry polish concrete that's not cured enough, you never get anywhere. You just keep fighting scratches, and they keep coming back. So it's very important with dry polishing to practice on good hard concrete so you know what you're doing and know what to look for. And finally, if you deal with dry polishing, the resin pads can glaze over. So instead of the pad wearing away fast, what happens is it actually melts and smears over. And so if you're spinning then slow down and spin too slow, you're riding on a layer of glazed pad that covers your diamonds and nothing happens. Or the pad melts and you get smearing where you actually get melted plastic on the surface of the concrete, or you get that pad dust residue that packs into the pores, and all of a sudden your white concrete turns brown because you have this pad residue. So all these factors are a downside of dry polishing that you have to deal with. And by not dry polishing, or by not dry honing and not dry polishing at 400 grit or 800 grit, you eliminate a lot of these problems, because the last two grits, the 1500 and 3000 grit dry, are very, very gentle. And so you're less likely to scratch, you're less likely to discolor the surface, you're more likely to be successful. So skip all the other grits and just go to the last two grits. Now that doesn't mean you're going to have 100% success, because here's the same piece of concrete that I showed you before that was dry polished. So those are the 400 and 800 grit scratches. That's a close-up, but you can see them quite clearly. And then I managed, after many minutes, to get most of them out with a 800 grit and the 1500 grit. And I was dry polishing with the 3000 grit. So the photo on the left is 3000 grit, and I pushed down a little too hard on one edge, and all of a sudden I got these giant swirl marks from a 3000 grit pad that shouldn't. I mean, you can polish glass with a 3000 grit dry pad, and there are these huge swirl marks. I had to go back to the 200 grit to get them out. That's how deep they were. So it was very, very frustrating. I take one step forward and about 30 steps back, and the reason why I had those problems was this, again, was only 2-day-old concrete, had not been densified, too young, and it was a cream finish. So I was setting myself up for failure, basically, by trying to polish something too soon. But I wanted to show you the effects of concrete age and different surface appearances and what some of the problems can happen. Had this concrete been well cured, had been densified well, the likelihood of that happening would be much, much lower. And you'd really have to work hard to do that. So don't feel that you could get these kind of scratches all the time. It's only if you do things improperly. So the keys to success with polishing concrete are simple. It starts with making very good concrete. Make great concrete. Make the best concrete you can. And let it cure. Give it time. It needs time to fully, not just harden, but the microscopic structure of it to develop so that it doesn't fall apart, generate cuttings that can chew up the surface and crumble. Give it time to do that, and then densify it, and give those densifiers time to react. And then when you do start polishing, start wet and finish dry. And then finally, never skip grits. Don't try to save time by going from 100 to 400 grit. You're actually wasting time. They make all those grits for a reason. Use them. And that's the key to polishing. So with that, I'll answer questions. I see there's a whole bunch of them. So let's... Nope, I think we answered the questions as we were going, so there are no questions. With that, we're going to sign off, and we will have this up and running and ready for viewing as a recording Tuesday. Thanks for attending. Bye-bye.